Hey guys, Assalamu alaikum. In this video, we'll be looking at some built-in functions that work with iterables or data structures. So I've made a few variables here, each one assigned to a data structure, my list, set, and the other three mentioned here, all containing numbers 1 to 4, with our dictionary's odd number keys assigned to even values. Aight. Now let's test out a few functions on them. I'll start with casting functions. There's one called list, which converts any sequence of items to a list. So let's try it out on our tuple, assigning it to a variable casted, and a print statement for it here. Running this will show that my tuple converted to a list in the console. Quite a useful function, especially in cases where you'd like to apply list operations on a tuple. You can then convert it to a list, and then also back to a tuple. So this function simply does as its name suggests, casting a collection to a tuple. Printing this out will show our tuple in the console. So what really happened was, first we casted our tuple to a list, then this list casted to a tuple. Sweet. You're now probably wondering that all these data structures have their own casting functions, and that's 100% correct. So we can cast other iterables or data structures to lists, tuples, sets, dictionaries, and strings. So let's do something interesting. We'll try converting all our objects here to the respective data structures. Let's first make a dictionary of these objects as values to their name keys. And I'll use a for loop to go through this dictionary, where we can have counter variables key and value to fetch the names and objects respectively from collections.items. And then I'll set up a formatted string per iteration to present each collection's casting to a data structure. So let's go with casting our objects to a list and a tuple first. Sweet. Running the program will show each object's casting to a list and a tuple here. You'll see that list and tuple casting also worked on our set, dictionary, and string. Notice that my dictionary casted to a list and a tuple with its keys as the items here, 1 and 3. Also notice how our string got casted to a list and a tuple, with its characters now separated as individual items per collection here. So this can be a neat trick to separate items that may be tightly stored together as a string. Now we'd see similar results by casting each object to a set, with one difference that all these results here would be in the form of curly braces. And let our second conversion be of the type string. Printing this out will show the following below, each object casted to a set and a string. Awesome. Now let's look at applying dictionary casting on these objects. The dict function requires a collection of key value pairs in the following form, so our list, tuple, and other objects would have to be of this form first. I'll use an example from our dictionary's key values by using .items and then converting this to a list. Now this is a valid object that works with the dict function. By printing this out, you'll see our object in the form of a dictionary here. In fact, by just applying my dictionary as a parameter, we'd still get the same result below. Basically, the dict function only takes in a collection of key values, so we can have, for example, a set of key value tuples, or also a tuple of key value lists. And these objects can be casted to dictionaries. Doing this for both of them will show in the console our respective dictionaries. Now these casting functions can be applied on other iterables, like a range object. So if I had a range of numbers 0 to 10 and applied list casting on this, you'll see in the console that we get a list of our numbers 0 to 10. Pretty cool, eh? And the same goes with applying set or tuple on this range of numbers. We'd get the same numbers as items of the new casted form. Awesome. Now let's look at other functions. Say I had the same list of numbers but in reverse order, 10 to 1, and say you'd like to order these numbers in ascending form. That can be done simply by applying the function sorted, which literally sorts out your collection by its data type contained inside. So we now have a list starting from 1 going up to 10 here. Sweet. And we can do the same for our string. Say I had a reversed version of it as shown below. By applying sorted on it, we then get a list of string numbers in ascending order. Cool. So this function sorts an iterable in ascending style with respect to its element's data type. Now say you'd like to get a list of items in reverse order, say from my set. We can then apply the same function but with an optional parameter, reverse as true. This will then produce a reversed list of our set's items as shown in the console. Awesome. Moving on to the next function, sum. Now just by the name of this function, it may seem straightforward to you that it basically returns the sum of your collection's items. And these items can only be of the form integer or float. So we can't, for example, apply it on a list of strings. Using a list string of our string numbers, we'd get an error in the console after printing this. So by using any other iterable, like my list, we'll return the sum of our numbers 1 to 4 as 10 in the console. And this function will return the same sum for our tuple and set. But for my dictionary, it will only return the sum of its keys, 1 and 3, which is 4 as shown here. To get the sum of its values instead, simply fetch the dictionary's values and apply a sum to it, then it will show the sum of 2 and 4 as 6 here. Now we know that by adding a string to another string, we get a concatenated string of the two. And you're probably wondering that the sum function could have concatenated our string numbers inside the list version of our string, but this function only works for numeric values. To concatenate a list of strings, Python suggests a function called join. So this one only takes in a collection of string items, which can then be joined by a separator mentioned here before join, say a comma. Printing this out will show our string of characters separated by commas. And we can define any separator here to join our characters with. Pretty awesome function, I'd say. Alright, next up I'll mention two functions for iterables, called max and min. These functions simply return the maximum or minimum values respectively from your collection of items. So applying max on my tuple will return the number 4 as the biggest number in our tuple. Similarly, for my dictionary, the max function will find the biggest value amongst the keys inside here. So we'd get 3 printed out below. Getting also the minimum value for our set, which will be 1. And surprisingly, the max and min functions work on a list of strings, or even a string itself. Applying the min function on my string will show number 1 fetched as the minimum value. And there's no issue of having a string with non-numeric characters, as I added ABC in my string. The max and min functions will look at the Unicode numbers of these characters. So running the program again will show in the console that C is the smallest character in my string. Awesome. Now for the last segment of this video, I'll mention 2 more functions that can be applied on iterables. So these are simply called all and any, and what they do is check through your collection of items for any true or false values. For the all function, its job is to check that all your values are of the true type. If so, this expression will return a Boolean value, true. So as I tested this out on my tuple, you'll find that we get true returned in the console, since all the numbers in our tuple are true values. But if I, however, added 0 in the tuple, running the program then will show a false value returned. This is because the number 0 is really just the value false. So our Boolean values have their own numeric values as 1 and 0 respectively. In the case of our collections, the numbers 1 to 4 here are non-zero numbers, which are seen as true values by the all and any functions. Since we added a 0 in the tuple, this all expression returned false. If I applied any on our updated tuple now, we'd get true returned in the console. This is because the any function checks for at least 1 true value from your collection. So this tuple contains 4 true values, therefore giving a result true. If we had instead used a list of zeros, this any expression would then throw a false value in the console. And putting in a mix of Boolean or numeric values wouldn't matter. The zeros and false would all be read the same and will return a false here below. Sweet. Alrighty then. We've gone through some built-in functions for iterables, and we've reached the end of this video. There are a few other functions that can be applied on iterables or data structures. I'll probably mention a few in future tutorials. For the next few videos, I'll likely go over applying sequence comprehensions and making user-defined functions. I hope you found this video helpful. If it was, give it a like or a subscribe, and stay tuned for the next one. Thank you so much for watching. I hope you have a good day, take care, and assalamu alaikum.